The infamous Yellowstone hotspot located in the USA has kept the world on edge for many years now. The volcanic hotspot is responsible for large-scale volcanism in several states including Idaho, Montana, Nevada, Oregon, and Wyoming. The hotspot formed when the North American tectonic plate moved over it, and through a succession of caldera-forming eruptions, it formed the eastern Snake River Plain. This also resulted in the formation of calderas including Island Park caldera, Henry's Fork caldera, and the Bruno Jarbidge caldera. Currently, the hotspot lies under the Yellowstone caldera. The most recent caldera-forming super-eruption rocked the region almost 640,000 years ago. It is now called the Lava Creek eruption, and it resulted in the formation of the Lava Creek Tuff and the most recent Yellowstone caldera. Though it doesn't mean the supervolcano isn't a ticking time bomb that could erupt any day and cause unimaginable destruction in the region. Scientists might not be able to pinpoint when the catastrophic events might occur or what might set them off, but the recent studies and data obtained from the caldera suggest that we may have been underestimating the risk it poses. The Yellowstone caldera is located in the Yellowstone National Park in the western United States. The caldera measures a whopping 70 by 45 kilometers across. The park itself is spread across 2,219,791 acres. That's actually more than the combined area of Delaware and Rhode Island. The major chunk of the Yellowstone National Park and the caldera fall in Wyoming, but the park itself extends into Montana and Idaho too. On March 1, 1872, the 42nd U.S. Congress established and signed the park into law with the Yellowstone National Park Protection Act. The vibrant landscape boasts lakes, canyons, rivers, and mountain ranges. It formed during the last three super-eruptions over the past 2.1 million years, the oldest being the Huckleberry Ridge eruption that occurred 2.1 million years ago. It was followed by the Mesa Falls eruption that happened 1.3 million years ago, and finally, the most recent Lava Creek eruption that occurred about 640,000 years ago. The caldera is an ancient supervolcano that has remained dormant for hundreds of thousands of years, but it was responsible for causing some of the grandest eruptions in the past. More than half of the geysers and hydrothermal features powered by volcanism are situated in the Yellowstone National Park. Rocks from the past volcanic eruptions cover most of the land in the region. The calderas lie over the Yellowstone hotspot under the Yellowstone Plateau. This is where the light but hot magma from the Earth's mantle rises to the surface. The hotspot apparently moves across the terrain in an east-northeast direction and is responsible for the eastern half of Idaho's Snake River Plain, but in reality, the hotspot is much deeper than the surrounding area, and it remains stationary while the North American plate moves west-southwest over it. This hotspot has generated a succession of explosive eruptions and multiple less violent floods of basaltic lava over the past 16.5 million years. Almost a dozen of these eruptions were so massive that they are classified as super-eruptions. The Yellowstone supervolcano is a volcanic field that produced the latest three super-eruptions in the Yellowstone hotspot, along with an additional smaller eruption. This resulted in the creation of the west thumb of Yellowstone Lake. The three super-eruptions formed the Island Park caldera, Henry's Fork caldera, and the Yellowstone caldera, respectively. Of these, the Island Park caldera super-eruption that formed the Huckleberry Ridge Tuff was the largest and spewed about 2,500 times more ash than the 1980 Mount St. Helens eruption. The Yellowstone caldera produced the Lava Creek Tuff, while Henry's Fork caldera formed the smaller Mesa Falls Tuff. Henry's Fork is also the only caldera from the Snake River Plain Yellowstone hotspot that is plainly visible even today. Since the last eruption, some 640,000 years ago, many non-explosive eruptions of lava and comparatively less violent eruptions have occurred in near the Yellowstone caldera. The most recent lava flow occurred almost 70,000 years ago. Another violent eruption excavated the west thumb of Lake Yellowstone about 174,000 years ago. Smaller steam explosions also keep occurring here. And about 13,800 years ago, an explosion left a 5-kilometer diameter crater at the Mary Bay on the edge of Yellowstone Lake. Nowadays, most of the volcanic activity is exhibited by the several geothermal vents scattered across the region, including the popular Old Faithful geyser. The volcanic eruptions and the consistent geothermal activity are a result of a massive plume of magma that is present below the caldera's surface. The magma in this plume contains gases that remain in dissolved form because of the extreme pressure under which the magma is contained. If, by some mechanism, this pressure is released to an adequate level by a geological shift, then some of the gases bubble out and magma in turn expands. This can actually set off a chain reaction, and if the expansion leads to further relief of pressure, for instance, by blowing the crust material off the top of the chambers, it could lead to an incredibly large gas explosion. According to the 2013 analysis of earthquake data, the magma chamber is almost 80 kilometers long and 20 kilometers wide. It also possesses about 4,000 cubic kilometers of underground volume, and almost 6 to 8% of this was filled with molten rock. This came as a shock as scientists had not expected the chamber to be this huge. It is almost 2.5 times larger than scientists previously assumed it would be. However, they do believe that the proportion of molten rock in the chamber isn't high enough to trigger another super eruption anytime soon. Research from the Arizona State University suggested that before the last massive Yellowstone super eruption, magma surged into the chamber in 2 large inflows. A study of the crystals obtained from the Yellowstone lava indicated that before the last super eruption, the magma chamber experienced a rapid rise in temperature and change in composition. This analysis suggested that the magma reservoir at Yellowstone can reach eruptive capacity and trigger a super eruption within a span of decades and not centuries, as volcanologists had previously speculated. The source of the Yellowstone hotspot is somewhat controversial. While some geoscientists think that this hotspot is the effect of integration between local conditions in the lithosphere and upper mantle convection, others believe in an origin in the deep mantle. It's considered controversial because the hotspot kind of suddenly appeared in the geologic record. Also, the Columbia basalt flows appeared at almost the same time, thereby leading scientists to speculate that they shared a common origin. The Yellowstone traveled to the east and northeast, the Columbia disturbance moved northward and eventually subsided. In 2018, an alternate theory to the mantle plume model was put forth. According to this theory, the volcanism may be caused by upwellings from the lower mantle that resulted from water-rich framers of the Farallon Plate descending from the Cascadia subduction region sheared off the subducted spreading rift. The largest supereruption of the Yellowstone caldera, the Lava Creek eruption, ejected approximately 1,000 cubic kilometers of rock, dust, and volcanic ash into the atmosphere. All the previous supereruptions at this supervolcano have been global disasters, and today scientists are trying to predict whether this bomb will explode or fizzle out. It hasn't arisen from its deep slumber in the last 70,000 years, but now that the scientists know that it's capable of waking up and destroying the region within decades, they're being more vigilant. The period of slow, steady rise has many scientists wondering whether the massive volcano might erupt in the near future. But what is a supervolcano, and why are volcanologists worried about this particular one? Supervolcanoes can be defined as volcanoes with a documented past eruption having a volcanic explosivity index of 8, which is also the largest recorded value on this index in human history. The volume of deposits for these volcanoes is always greater than 1,000 cubic kilometers. Supervolcanoes are formed when magma from the mantle of the Earth makes its way to the crust but is unable to break through it. The pressure in the massive and continuously growing pool of magma keeps building up until the crust finally gives way. Unable to bear the pressure, it ruptures. This can happen at hotspots like the Yellowstone caldera, the Hawaii hotspot, Louisville Ridge, St. Helena hotspot, Canary hotspot, and more. The supereruptions having a massive volume are often associated with huge igneous provinces where lava and volcanic ash can cover extensive areas. Supereruptions can be immensely destructive. They can induce long-lasting climate changes, kill entire species, and are even capable of wiping out humanity. The Yellowstone supervolcano is a giant with a string of hazardous eruptions in its history, and it's possible that the massive supervolcano is slowly waking up from its deep slumber. The sleeping giant does stir up occasionally, but so far it hasn't fully woken up. When it is finally up and ready to erupt, it will not be easy to deal with this powerful beast. Dr. Steve Anderson, a volcanologist and earth sciences professor at the University of Northern Colorado, has said that scientists actually don't know what to expect in case the Yellowstone supervolcano erupts. In July 2022, the University of Utah seismographic stations reported 59 earthquakes in the Yellowstone National Park region. These stations operate the Yellowstone seismic network and analyze the data obtained from it. The biggest event of that month was a 3.1 magnitude minor earthquake that was located almost 14 miles south-southwest of the Mammoth Hot Springs. It was recorded on the 30th of July at 1:44 a.m. This earthquake was a part of a swarm of 13 small quakes that shook the ground in the region between the 29th and 30th of July. These earthquakes and others like them account for almost 50% of the seismic activity in the Yellowstone region. In a bubbling caldera of the Yellowstone National Park in northwestern Wyoming is a scar of a 640,000 years old monstrous volcanic eruption. The 3,472 square mile park surrounding the caldera boasts several geologic wonderlands of sprouting geysers and effervescent pools. All of these thermal features are ultimately driven by the magma and superheated fluids flowing in the rocks beneath the surface. One famous area amongst these is the Norris Geyser Basin located in the northwest from the caldera. It contains more than 500 hydrothermal features. These feisty geysers and hot pools are changing on a daily basis, but along with these changes, another much larger transformation has also been underway. For more than 20 years now, an area larger than the city of Chicago, centered close to the basin, has been inflating and deflating by several inches in the form of erratic bursts. It's actually not easy to pinpoint the exact causes of any particular movement in a hyperactive volcanic region like the Yellowstone, though a recent study published in the Journal of Geophysical Research, Solid Earth, might be able to explain why this huge pocket of landmass has been inhaling and exhaling. Daniel Zurischen, a research geologist at the U.S. Geological Survey's Cascades Volcano Observatory and one of the co-authors of this new research, thinks that in all likelihood, Norris has been a center of deformation for a long time now. Scientists used tens of years of satellite-based radar and GPS data of the Norris Geyser Basin to figure out and create a model of what may have happened below its surface based on the changes occurring above ground. In the late 1990s, a body of magma intruded under Norris and fluids trapped in this magma bubbled out. These made their way through the rocky labyrinth above them, and as these fluids got stuck between the rocks, the pressure would build up. This would lead to a rise in the ground, and when these fluids managed to escape elsewhere, the ground would eventually deflate. Nowadays, the magma-derived fluids might be sitting dangerously close to the surface, only a mile or so beneath the ground. This research doesn't blatantly propose that the supervolcano caldera is any more likely to erupt now, but these geologic movements will help volcanologists explain why the infamous Steamboat Geyser of the park, which is also the world's tallest active geyser, has been erupting at a record-breaking speed since March 2018. Researchers have also suggested that the changes below Norris might indicate that there's a slightly higher chance of hydrothermal explosion taking place in the basin. The geology of Yellowstone is pretty complicated and elusive. It's quite challenging to investigate the subsurface here, but researchers have reached a consensus that the injection of a huge body of magma and the fluids that escaped during this event are reliable explanations for this breathing behavior of the ground at Yellowstone. According to Michael Poland, the scientist in charge at the U.S. Geological Survey's Yellowstone Volcano Observatory, they're just beginning to understand how dynamic the Norris Geyser Basin and the entire volcano actually is. This basin is regarded as Yellowstone's oldest thermal area, and the evidence of thermal features here date back almost 115,000 years. It's also the hottest part, with temperatures rising as high as 459 degrees Fahrenheit, 1,000 feet or more beneath the surface. The Steamboat Geyser in the area is a great example of how drastically and unexpectedly this scalding patch of Yellowstone can change. Between 1996 and 2004, an 18-mile-long area in the basin rose about 4.7 inches and then sank back 2.8 inches between 2005 and 2013. The same region suddenly rose again at a rate of 5.9 inches per year between 2013 and 2014. This was the highest uplift ever observed within Yellowstone National Park. The Norris Geyser Basin area was hit by a 4.9 magnitude earthquake in March 2014, and it brought an end to the apparently unstoppable uplift. The ground again fluctuated between sinking and rising until 2019, when it eventually stopped. Today, the basin is 5 inches higher than it was in 2000. The data from radar and GPS satellites was used to track this deformation in the Norris Geyser Basin. Geologists think that this began when magma reached a level just 9 miles beneath the surface between 1996 and 2001. The basin outside the northwestern rim of the youngest caldera of Yellowstone supervolcano sits on a line of faults and vents called the Norris Mammoth Corridor. Zarijan thinks that the two weak zones intersecting one another could be an ideal place for the magma to find an easier way to intrude. The team now suspects that the magma-derived fluids are sitting just under the surface of Norris Geyser Basin. There are many hydrothermal explosion craters scattered over the region. These were caused by geologic pressure cookers of confined, scorching water that violently depressurized and flash-boiled into steam when the rock cracked. And experts believe that such events might occur again now that magma is so close to the surface. A new blast could potentially occur at any time in the Norris Geyser Basin, but major explosions are quite rare. It's more likely that hydrothermal explosions will occur if the fluids have pooled closer to the surface. But Zarijan has pointed out that the rocky plumbing networks underneath are significantly more complex, with small, undetectable changes consistently increasing and decreasing the chances of a blast. The period of slow and steady rise in the ground has a lot of scientists wondering whether Yellowstone might be nearing an eruption. If it does erupt, the main concern for the experts is the intensity of that eruption. According to Dr. Steve Anderson, the big question is, if Yellowstone started shaking tomorrow, what is there to expect? Now, scientists may not know what exactly to expect, but they have somewhat of an idea, and most of the experts think it won't be like Doomsday. Dr. Jacob Lowenstern has speculated that the current levels of unrest and activity at the Yellowstone supervolcano are not likely to produce a massive explosion in the near future. However, the level of recent underground activity has risen suspicions regarding the intensity of the eruption. In the past decade, the Yellowstone volcano has continued to rise at the fastest rate ever recorded. It also averages between 1,000 to 3,000 earthquakes every year. The majority of these are virtually unnoticeable, having a magnitude of 3 or less, but these quakes do provide an insight into how fast the magma chamber underneath the park is filling up. A rise in the shaking and rattling throughout the park might be a sign of a fresh batch of magma being recently fed into the reservoir. But despite the increasing tremors, scientists don't think the churnings in the magma chamber pose a threat anytime soon. But it's also noteworthy to point out that people haven't been around to analyze absolutely everything that happens in the caldera, therefore it's hard to predict what is actually going on under the surface. And this makes it difficult for the geologists and volcanologists to predict the next move of the supervolcano. Analysis of the distant past of the volcano does provide some information though. According to geologic evidence, we already know that Yellowstone produced 3 catastrophic eruptions in the last 2.1 million years. Volcanologists know that these eruptions occurred at gaps of 600,000 to 800,000 years. The remnants of the last big event that occurred about 640,000 years ago are scattered throughout the park and across thousands of kilometers of the surrounding terrain. All of the previous supereruptions spewed out gigantic amounts of volcanic ash, gases, magma, and volcanic debris that covered the majority of the continental US. Material from these eruptions has been found as far as Louisiana. After each of these eruptions, the Yellowstone volcano collapsed in on itself. It sucked in trees, mountains, and everything else in the surrounding landscape. This depression formed by the supereruption is called a caldera. And if a similar caldera-forming eruption occurs again, it would be a grave and colossal natural hazard. According to experts, the last supereruption of the Yellowstone supervolcano was at least 1,000 times greater than the devastating 1980 Mount St. Helens eruption that took the lives of 56 people and thousands of animals, and it burned hundreds of square kilometers of land in Washington and Oregon. So one can only imagine what 1,000 times more violent eruption will do to the region. The last massive blast from the Yellowstone supervolcano shot a fatal plume of hot ash, molten rock, and toxic gases thousands of meters into the air. 1/3 of the continent was probably plunged into complete darkness. The fast-moving currents of hot, dry rock fragments and gases called pyroclastic flows spread along the region at alarming speeds and buried or shattered everything that got in its path. The The magma spilling out of the ground scorched the once scenic and beautiful landscape for many kilometers. Some evidence of the last eruption is also visible in the Yellowstone caldera itself. The thick volcanic debris that remained after the eruption can still be seen in the Lava Creek Tuff. Back in July 2021, experts and the rest of the population were faced with the fear of the unthinkable. The Earth began rumbling beneath the Yellowstone National Park with swarms of more than 1,000 earthquakes, according to the U.S. Geological Survey report. This was the most seismic activity the park had seen in a single month since June 2017, when a swarm of more than 1,100 earthquakes shook the region. Luckily, these earthquakes were minor, with only 4 tremors measuring in the magnitude 3 range. The USGS report said that this activity was definitely above average, but this level of seismicity was not unprecedented and didn't reflect major magmatic activity. If it were the cause of quakes, they would have also noticed other indicators like changes in deformation style or thermal emissions, but no variations of the sort were detected. The University of Utah seismograph stations that were responsible for monitoring and analyzing quakes in the Yellowstone Park region recorded a total of 1,008 earthquakes in the region throughout the month of July. These quakes came in a series of 7 swarms, with the most energetic event occurring on July 16th. The USGS explained that these quakes were most likely the result of motion on pre-existing faults underneath the park. Fault movements are often stimulated by melting snow that leads to an increase in the amount of groundwater seeping under the park. This increases the pressure levels underground, according to researchers. Being one of the most seismically active regions in the US, the Yellowstone area is typically hit by 700 to 3,000 earthquakes annually, and most of these are unnoticeable to the visitors. The biggest earthquake on record in Yellowstone was a magnitude 7.3 Hebgen Lake quake that occurred in 1959. But why does the ground tremble so much here? The park actually sits over a network of fault lines associated with an enormous volcano buried deep underground, and it last erupted almost 70,000 years ago. Earthquakes occur here because the region's fault lines stretch apart and as the magma, water, and gas moves beneath the surface. These features also feed the famous geysers and hot springs of the park. The Yellowstone supervolcano has erupted numerous times in the past, with colossal eruptions occurring every 700,000 years or so. But what will happen if a supervolcano underneath Yellowstone National Park ever had another massive eruption? It would most likely spew ash for thousands of miles across the United States, damage buildings, smother crops, and shut down power plants. But that doesn't mean we should panic. The odds of this happening are fortunately very low. However, the Yellowstone volcano is thousands of times more powerful than any regular volcano, and that's why it remains an endless source of apocalyptic fascination, and it's not hard to see why. A team of scientists published a paper in Geochemistry, Geophysics, Geosystems in September 2014. It explored what a super eruption might look like. Among other things, they ascertained that the volcano was capable of burying states like Wyoming, Montana, Idaho, and Colorado in 3 feet of immensely harmful volcanic ash containing splintered rock and glass. It would also blanket the Midwest. This amount of ash is capable of killing plants and animals, crushing roofs, and shorting almost all types of electrical equipment. One of the co-authors of the survey, Jacob Lowenstern of the U.S. Geological Survey, stresses that the paper was in no way a prediction of the future. According to him, if Yellowstone did erupt again, there is a chance we may not suffer from the worst-case scenario. The main reason why Yellowstone gets so much attention from the public and press is the remote possibility of a future super eruption. And it's worth noting that despite being the center of attention, Yellowstone is hardly the only supervolcano out there. Geologists have discovered evidence suggesting the presence of at least 47 super eruptions in Earth's history. The most recent one of these occurred in New Zealand's Lake Taupo about 26,000 years ago. On average, the Earth has seen a super eruption every 100,000 years, but that is not an ironclad law. The most likely eruption scenario in Yellowstone is a smaller event that may produce lava flows similar to the ones that happened at Iceland's Bardarbunga. This would most probably be precipitated by a swarm of earthquakes in a particular region of the park while the magma makes its way to the surface. But in the unlikely event of a much larger super eruption, the warning signs would be much bigger and clearer. Lowenstern explained that we'd likely see intense seismic activity across the entire park. It could take weeks or months for those earthquakes to shatter the rocks above the magma before an eruption. So what if we did get a super eruption, an event substantially more violent than a regular volcanic eruption, ejecting 240 cubic miles of material and lasts for weeks or months? The lava flows would probably be contained within a relatively small radius inside the park. In fact, experts believe only 1/3 of the material would actually make it up into the atmosphere. The actual damage will probably come from the volcanic ash that will scatter across the US. In the paper, Lowenstern and his colleagues looked at both historical ash deposits and advanced modeling to conclude that an eruption would create an umbrella cloud expanding in all directions. A super eruption is capable of conceivably burying the northern Rockies in 3 feet of ash, destroying large sections of Wyoming, Idaho, Colorado, Montana, and Utah. The Midwest will get a few inches of ash, and the coast will probably see even smaller amounts. The exact distribution would, however, depend on the time of the year and weather patterns. But any of these scenarios would be terrible news. This much volcanic ash would kill people, plants, animals, and crush buildings. Even a few inches of volcanic ash is capable of destroying farms, clogging railways, causing respiratory ailments, blocking sewer lines, and even shorting out transformers. Air travel across most of North America will have to shut down. A gargantuan volcanic eruption would also affect the global climate. Volcanoes can spew out sulfur aerosols that reflect sunlight back into the atmosphere to cool the climate. These particles, however, remain in the atmosphere for a short period, so this effect will most likely be temporary. But it can still be pretty dramatic. Back when Pinatubo erupted in 1991, it cooled the entire planet by almost 1 degree Celsius. The Tambora eruption in 1815 actually cooled the planet enough to damage crops across the globe. And these were much smaller eruptions as compared to what a supervolcano is capable of. Fortunately, the odds of a super eruption in the Yellowstone volcano aren't very high. According to USGS, if we look at the past 3 eruptions, the chances of Yellowstone erupting in any given year are 0.00014%. The chances of Earth getting struck by a civilization-ending asteroid are higher than that. But even this is not at all a good estimate, as it's not certain that Yellowstone erupts on a regular cycle or that it's overdue for an eruption. The Earth will definitely see super eruptions in the future, but these won't necessarily happen at Yellowstone. After all, volcanoes do die out too. The magma chamber underneath the Yellowstone volcano is being affected by 2 opposing forces, the heat welling up from beneath and the relative cold from the surface. If the heat coming from below fizzles out, the chamber could freeze, eventually turning into a solid granite body. It's also important to note that the volcanic hotspot is slowly moving northeast, and over a long enough timescale, it will move out from under Yellowstone, causing the supervolcano to eventually die out. There is, however, a chance that another supervolcano could emerge further in the northeast, but the hotspot would first have to heat up and melt the cold crust first, which could take 1,000,000 years or even more. But if the Yellowstone does blow up, the lava spilling out from the volcano will destroy just about everything in a 40-mile radius. Major cities including Denver, Salt Lake City, and Boise would be wiped out entirely. According to the Federal Emergency Management Agency, a super eruption in the Yellowstone volcano will estimatedly cause $3 trillion worth of damage. However, the unlikelihood of this happening doesn't mean that planning for a disastrous super eruption and efforts to prevent it are not necessary. NASA has recently detailed a plan to prevent the Yellowstone supervolcano from ever erupting again. They plan to ensure that it stays inactive, but they also want to use it to provide the surrounding area with electricity. The plan is pretty ambitious and risky, but the potential benefits of its success outweigh the demerits. First, they would drill into the volcano from the lower sides, outside the boundaries of Yellowstone National Park. Approaching from this direction would prevent the heat from making its way to the top of the chamber. Once the drilling concludes, water would be pumped into and back out of the supervolcano at high pressures. The existing water would be heated to a temperature of 350 degrees Celsius. In this way, the water going in will slowly cool the volcano, while the hot water coming out of it could be used to generate electricity. Yellowstone leaks about 6 gigawatts of heat, according to Brian Wilcox, a researcher at NASA's Jet Propulsion Laboratory, and drilling in this way, it could be used to create a geothermal plant. Besides the dangers inherent in any plan to drill into a supervolcano, the NASA proposal is mostly theoretical. No one knows whether it would work, and the cost of finding out would be a whopping $3.46 billion. But many scientists think that it would be worth every penny if it's successful. Today, geologists and volcanologists keenly monitor every hiccup and churn of this volcano for any signs of danger. They are quite optimistic that a catastrophic super explosion will not occur anytime soon, but there is no way of absolutely determining what might be happening under this potentially disastrous hotspot.